Compartilhar a tela, só um minutinho.
Você deve encerrar o compartilhamento, isso, para ela poder fazer o compartilhamento dela, da tela dela. Oi, Ellen.
Olá, boa tarde.
Boa tarde. Está conseguindo compartilhar?
Vou colocar agora.
Certo.
Está dando para ver?
Estamos vendo. E ouvindo também. Obrigada, boa apresentação.
Obrigada. Good afternoon. My name is Ellen. I'm a material engineering student at UFRPE, and today I'll be presenting my last work, which theme is the statistical study for the use of nanostructured material in the removal of Congo red and Ingo carmine dyes in aqueous medium. Every year, the textile industry consumes over 90 trillion liters of water, which means 4% of the world's annual freshwater abstraction. The textile processing industry is heavily dependent on water in practically all stages of the production process, generating high volumes of effluent contained by dye residues, which have high stability and are extremely resistant to water and biodegradation. Pernambuco is home of the second large national producer in the clothing and fabric industry, producing around 800 million pieces annually. And most of these fabrics discharge contain effluents directly into the river. In this work, we study the absorption power of iron oxide nanoparticles against the Congo red and Ingo carmine dyes. The Congo red has red coloration, cationic behavior, and is potentially carcinogenic. And the Ingo carmine has blue color, anionic character, and has ketone groups. This work was based in previous works developed by our research group, dedicating exclusively to the statistical study of the nanoparticles absorption and applications. Starting the experimental procedure, we have the synthesis of the nanoparticles using the chemical co-precipitation technique with aqueous solutions of ferrous sulfate with ammonium hydroxide under ultrasound. Approximately 1.4 grams of ferrous sulfate was diluted with water, and we added some sulfuric acid. And then the solution was placed in the ultrasonic bath at 50 degrees, and 50 milliliters of ammonium hydroxide was slowly added. Then the system was placed in water bath for 10 minutes at 50 degrees. And with the aid of a magnetic, we decanted the nanoparticles, washed them with hydrochloric acid, and then we placed in the centrifugation and drying for 24 hours at 60 degrees. After the synthesis and the drying period, we obtained a fine and magnetic powder. We proceed the characterizations of X-ray diffraction, infrared spectrum, and magnetization. As we can see, the tetragonal phase of magmat was indexed, and with the hysteresis curve, we observed that the particles has iron magnetic behavior. Moving on to the analysis of the dye solutions through spectroscopy, we in the visible region, the maximum wavelength of absorption was determined for the solutions of Congo red at 480 nanometers, and for the indigo carmine at 610 nanometers. The Congo red was in the blue-green region, which is the complementary color to the red, and for the indigo carmine, indigo carmine was in the orange region, which is the complementary color of blue. In the construction of the calibration curves, the equations of the straight line were obtained, and it can be observed that both systems obey to the Lambda law. After this analysis, the real work began. As we'll see next, the conclusions are very similar for the Congo Red and for indigo carmine, only differing in the value of the percentage of absorption. Starting with the Congo Red, we have the Pareto chart that exposes the factors and their significance at 95% of confidence. And for the values presented, we can see that only the nanoparticle mass and the concentrations of dye solutions are significant. As for nanoparticle mass, we can say that it was expected since the absorption intensity is proportional to the specific surface area, and the adsorption is a surface phenomenon. The greater the number of the adsorption site, the greater will be the percentage of adsorption. As was significant the concentration of dye solution, we can say that when we are going from a lower level to a higher level, such as 10 milligrams per liter to 20 milligrams per liter, the response of this work, the percentage of adsorption will be disadvantaged, which is with agreement what we found in the literature. And for factor 3, the interaction time, there was no evidence of the significant influence in this evaluated system, and the individual variation of the interaction time did not interfere directly in the average percentage of adsorption. The geometric interpretation of the factorial design is the cube, which presents all the tests performed in the respective values of the average responses in each vertex. It can be observed that the tests that provide the highest percentages of adsorption were test 2, which combines the higher mass, the lower concentration, and the lower time, and test 6, which combines higher mass, lower concentration, and higher time. Both tests showed values greater than 90% of adsorption. As for test 2 was performed with less time, it should be chosen since the energy cost will be lower, being more economically viable. This very significant response in the percentage of adsorption of Congo Red can be explained by the presence of amine groups in the structure of the dye, and these groups must have high affinity with the surface of the nanoparticles. As for Congo Red, the significant factors for the factorial design of adsorption of the indigo carmine were similar, and only the mass of nanoparticles and concentration of dye solutions. In similar work carried by our group, it was observed that there was no evidence of the significance of the time. And for this system of the interaction between nanoparticles and the indigo carmine, the higher percentages of adsorption were such as in Congo Red, test 2 and test 6, and such as in Congo Red, we must privilege the test 2 that is carried out with lower time, with less time. So in addition, it was also possible to study the real application of this work in an industrial processing scale by calculating the cost of a large scale production of the nanoparticles. And then we elaborated an adsorption scheme for the effluent treatment in the industry. As shown in the figures, the adsorption on an industrial scale can occur inside the tank, which can be the same tank as the washing fabrics, where the nanoparticles are added to interact with the effluents for around 120 minutes under agitation. And after the adsorption and the deposition of the nanoparticles in the bottom of the tank, the treated effluent can be drained, and in the end, will only remain the nanoparticles and a small volume of the effluent. In previous studies, it was possible to conclude that the adsorption of indigo carmine dye by the nanoparticles, and consequently, the Congo red is a reversible process, and the desorption of the dyes and the reuse of the nanoparticles are viable. So after we do the desorption, the nanoparticles can be reused for at least 5 removal cycles. As conclusions, we have that the magnetic nanoparticles were synthesized by co-precipitation and characterized by XRD infrared spectrum and magnetizations. The dye solutions of Congo red and indigo carmine were prepared and characterized. For the Congo red and the indigo carmine, the main effects were only the mass of nanoparticles and the dye concentration at 95% of confidence, while the time interaction and the interaction between factors were significant. And it was possible to define that the test that presents the last time average response for the 2 dyes. The test that matches the greater mass of nanoparticles, the lower concentration of dye, and the last time were more efficient, and it can be applied to the real effluent. I would like to thank the founding institution, my advisor, my colleagues, my university, and everyone for your time and attention. Thank you.
Obrigada, Ellen. Foi uma ótima apresentação a sua. Parabéns, viu? Tenho aqui uma pergunta para você no chat, tá? Mariana Silva, aluna da nossa pós-graduação aqui de Engenharia Física, quer saber o que despertou o seu interesse em usar 2 comprimentos de onda diferentes.
Eu vou responder em português, tá? Então, eu não usei 2 comprimentos de onda diferentes. Foi o comprimento máximo de absorção de cada um dos corantes. No caso do vermelho Congo, é 498 nanômetros, e no caso do índigo carmim, 610 nanômetros. A gente determina isso experimentalmente.